Good morning, dear students. My name is Ferhan Mazher, and today is 3rd of the April 2022. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels of Physics, and the code of the subject is 5054. Today, we have set our hearts to solve a theory paper, and we have selected May June 2013 to paper. In this video, we are going to attempt the section B of this paper. The section A of this paper we have already solved, and we have uploaded that video in my YouTube channel. You can find that. So let's start today's paper, and this is about the section B of this paper. So in front of you, the section B of the May June 2013 to paper is showing up. So this section B starts from the question number 9. Figure 9.1 shows a flask partly full of a liquid and partly full of air. So here we have a flask. Here we have the liquid in the flask, and here we have the air. This is a tube, and this tube has liquid in it. So the height of this, the liquid in the tube is 0.15 meter. When the flask is heated, the pressure of the air inside the flask increases and the liquid rises up the tube. Explain using ideas about molecules why heating the air inside the flask causes the pressure to increase. You see, this air, when you will heat this flask, the molecules of the air, they will start moving faster. So their kinetic energy will increase. So what will happen? They will move fast. So their collision frequency with the surface of the liquid will increase. So because they have now more kinetic energy, when they collide with the surface of the liquid, they will exert a larger force. So due to the increase in the collision frequency and due to the larger kinetic energy, and because they are exerting more force when they are colliding with the surface of the liquid, the pressure of the air in the flask will increase. Let me show you my answer. So question number 9. Okay, so here we go. Air molecules will start moving faster. They will have more kinetic energy. They will exert more force on hitting the surface of the liquid. Collision frequency of the air molecules with the liquid will increase. So that's why the pressure of the air will increase. So let's look at the marking scheme. Air molecule hit walls, liquid surface. Air molecules move faster, greater kinetic energy. Air molecules hit more often, more frequently, greater rate, harder, more force, or liquid molecules evaporate. So these are the 3 marks, and you can see we have written all these points. Okay, so the next question. A teacher uses the flask as a thermometer. He marks the liquid level at 0 degrees centigrade and at 100 degrees centigrade. Describe how the teacher obtains these temperatures. So very simple. He will place the flask in the melting ice, and when the level of the liquid will become steady in the tube, he will mark it at 0 degrees centigrade, and then he will place the flask in the steam of the boiling water. And when the level of the liquid in the tube will become steady, he will mark it. So this is how it will be done. He says, state 2 ways in which the thermometer can be made more sensitive. You can use a liquid which expands more, and you can increase the volume of the air in the flask. Okay, so let's see my written answers. So here we go. He places the flask in melting ice and mark the level of the liquid in tube. Place flask in steam of boiling water and mark the level of the liquid in the tube. Use liquid which expands more and use more volume of air. So this is our answers. Okay, so let's have a look at the marking scheme. The marking scheme says the flask is pure melting in pure melting ice and water, flask in pure boiling water, above the boiling water at 1 atmospheric pressure. Thinner tube you can use, or larger flask you can use, more air, less liquid. Use liquid that expands more. So hopefully you understand. Our answers are right. Okay, so the next question. The thermometer has a non-linear scale. Explain what is meant by a non-linear scale on a thermometer. A non-linear scale means that the distance between the deviance on the thermometer, that distance is not uniform. It means that the expansion in the liquid of the thermometer is not uniform for the same rise of temperature. So let's see what we have written in answer. Okay, so here we go. Different distance along scale moved by liquid in thermometer for same rise of temperature. So let's have a look at here. Deviance are not equally spaced, or scale not uniform, not proportional. Different distance along the scale for same temperature rise, or different change in temperature for same distance along the scale. Okay, so our answer, that is, we are done with the B part. Okay, he says the inner cross-sectional area of the tube is 5 × 10⁻⁵ meters square. The density of the liquid in the tube is 1200 kg per meter cube. The distance between X and Y is 0.15 meter. The gravitational field strength G is 10 Newton per kg. Calculate the mass of the liquid in the tube. Okay, so we know the cross-sectional area of the tube in which we have the liquid, and we know the length of that tube. So we can find the volume of the liquid there in that tube. The volume is area multiply cross-sectional area. Is area multiply the length of the tube. So once you have the volume, then you can apply the formula of the density. Density is equal to mass divided by volume. So mass will be density multiply volume. You know the density, you know the volume. You multiply them, you get the mass in kg. And then the question is the weight of the liquid in tube. So once you have the mass in kg, you can find the weight. W is equals to mg. So let's have a look at here. So the volume of the liquid will be the cross-sectional area of the tube multiplied by the length of the tube in which you have that liquid. So 5 × 10⁻⁵ multiplies 0.15. It will be 0.75 into 10 raised to power minus 5. That will be 7.5 × 6 meter cube. So we know that density is equal to mass divided by volume. So mass will be density multiply volume. So 1200 multiply 7.5 × 6. So you will have 0.009 kg. So 0.009 kg is the mass. Okay, the next question is the weight of the liquid in the tube. You know the weight is W is equals to mg, that is 0.009 multiplied 10. So it will be 0.09 Newton. Then the question is the pressure at the bottom of the tube caused by the liquid column between X and Y. You know the pressure of the liquid is rho GH. Rho means the density, G means the gravitational field strength, and H means the depth of the liquid column. So it is 1200 multiplied 10 multiplied 0.15, and it will be 1800 Pascal. So we are done with this. So let's have a look at the marking scheme first. So 0.009 kg, our answer is right. 0.09 Newton, our answer is right. 1800 Pascal, our answers are right. Okay. So now the question is, when the flask is completely full of liquid, the liquid moves up the tube a smaller distance for the same temperature rise state Y. Because when you have fully filled the flask with the liquid, and now there will be only liquid. So for the same rise in the temperature, the expansion in the liquid is less as compared to the expansion in the gas. So that's why there will be a smaller distance for the same rise in the temperature. So let me read my answer and then we will go. Okay, liquid expands less as compared to the gas for the same rise of temperature. Okay, so let's have a look at the marking. Liquid expands less than air or greater forces between liquid molecules. So we are done with the question number 9. Okay, so the question number, the next question is question number 10. A student traces the path of a ray of blue light as it enters and as it leaves a glass prism. Figure 10.1 shows the trace bit obtained by the student. Figure 10.1, draw and label at the point B the normal, the angle of incidence I, and the angle of refraction. So what I will do, I will take a protector, I will put it here. The crosshair of the protector will be at this point of incidence. And then I'll put the zeros of the protector will be on both these sides, on this straight edge of the prism. So I will put the dot on the 90 degree and then I will draw that line. That will be the normal. Normal makes 90-degree angle with the surface of the prism. And then the angle between the incident ray and the normal will be I. I will join this point B and the C point with each other with a straight line. And the angle between this refracted ray and the normal inside the prism, that will be the angle of refraction. So let me show you. I've done this. So this red line is the normal, and I have joined the B and the C with this black line. The angle between the incident ray and the normal is angle of incidence. The angle between the refracted ray and the normal is angle of refraction. So I and R, this is what they are asking. Correct normal by I, correct angle of incidence between the candidate's normal and the incident ray, correct angle of refraction marked between the candidate's normal and the BC. Okay, so next question. State in terms of the properties of the light waves why the light refracts at the B. You see, when the light enters into the prism at the point B, the speed of the light will decrease, the wavelength of the light will decrease. That's why the direction of the light will change, and we say that the light has refracted. So let me show you. At B, when I forgot to write here, B, when light enters from air into glass, speed of light decreases, wavelength of the light decreases. That's why the light will bend, and we say the refraction has taken place. Okay, decrease change in speed and wavelength. Okay, so our answer right. Okay, so move to the next question. He says that the angle of incidence for the ray of blue light at B is 45 degree. The refractive index of the glass is 1.5. Calculate the angle of refraction at the B. A 3 marks numerical, very simple. Let me show you. N is equals to sine I by sine R. So the N value, refractive index, is 1.5, sine 45, angle of incidence is 45, angle of refraction is question. So bring it here and 1.5 will go downstairs. So sine R will be equals to sine of 45 divided by 1.5. Just enter this value in your calculator, you will get 0.471. Then I will make R alone and the sine will go to the other side and it will become sine inverse. So in your calculator, you will write shift sine 0.471 equals to, and that will be 28.1 degrees. So 28 degrees is the angle of refraction. Hope you understand this numerical. 28 degree is the right answer, sir. Okay, so let's go to the next part. He says, the student performs another experiment with a ray of red light along the line AB. On the figure 10.1, show the path taken by this ray of light as it passes through and leaves the prism. You know, you can see that I have drawn that because the the colors which are formed after when the light, white light is dispersed by dispersion of the white light takes place. And here the colors, the band of colors you see, the code is Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. So the red is always above this blue line. So the red color will, its line will be, this one is showing the blue one. So the red will be here a little above the blue line. Okay, so this is how you have to do this. Because the red in that, the color of bands is always above the blue. Red bends less as compared to the blue. So this is what you have to show there. Refracts less at first phase and on correct side of the normal. Refraction at the second phase away from normal, so that the red ray and blue ray are diverging. Okay. So the angle of, sorry, now. The student performs another experiment with the semicircular glass block and a ray of white light. Figure 10.1 shows the path taken by this ray of light as it enters the glass at P until it hits the straight edge at Q. The student finds that there is no change in direction as the ray enters the glass at the point P, and that no light passes out of the glass at Q. Explain why the ray does not change direction at the P. You see, if you draw normal here and the point of incidence, you will find that the angle between that tangent and this incident ray is 90. It means that the light entering the incident ray is making 90-degree angle with the surface of the glass. So the light is entering basically along the normal. So whenever the light enters into another medium along the normal, that light do not change its path. So explain why no light passes out of the glass at the Q, because the angle of incidence here at Q in the dense medium is more than the critical angle. So the process of total internal reflection will take place. So the light will not come out here. It will not emerge. It will be reflected. Total internal reflection will take place. Let's have a look at the answers. So ray has entered along the normal to the surface of the glass at the point of incidence. That's why it has not changed its direction. Angle of incidence at the Q in dense medium is larger than the critical angle. So process of total internal reflection took place. Okay, so let's have a look at the marking scheme. Angle of incidence is 0 or ray along the normal perpendicular to glass. And second part is angle of incidence is larger than critical angle. So total internal reflection occur. So our answers are right. Then the question is on the figure 10.2, draw the complete path followed by this ray. So here the total internal reflection took place. So check how much is this angle of incidence. Same will be the angle of reflection here. And that ray will be like this. Let me show you, I have drawn this. Okay, so I have checked this angle of incidence, and this angle of reflection will be equal to this angle of incidence, and I have drawn that line. Reflected ray drawn correctly and emerging without refraction from the block. Okay, so the next question, he says the student directs the ray of white light into the glass along different paths so that the angle theta is slowly reduced. Describe what happens to the ray at the Q. So if you will decrease this angle of incidence, and when this angle of incidence will become less than the critical angle, so the light will emerge from here. And when it will come out, it will bend away from the normal. Eventually, light emerges from the Q into air. Light at Q will bend away from normal when it comes into air. So let's have a look at the marking scheme. We have given this, okay? So we will move to the next question. The next question is question number 11. A student places a small electric heater inside a cup of water, as shown in the figure 11.1. The student determines the electric power of the heater. In the space above the cup on the figure 11.1, draw the electric circuit that the student uses, include an ammeter, a voltmeter, and a power supply. So here you can see I have given the connections. I have connected a power supply. Here an ammeter has been connected. Ammeter should always be connected in series. And a voltmeter is connected, which is parallel to the heater. This voltmeter will tell you how much voltage is being used, and this will tell you how much current is being used. Power supply with the ammeter and a heater in series, voltmeter in parallel with the heater and power supply. Okay, so the next question. He says the voltage of the power supply is 12 volt and the current is 4.2 ampere. Calculate the electric power input to the heater. You know the power formula is IV. IV, I means the current, V means the voltage. So 4.2 ampere multiplied 12 volt, you will get the power in joules. So 4.2 ampere multiplied 12, and that will, sorry, I said joules, it's in watt, sorry. So 4.2 multiplied 12, it will be 50.4 watt. 50.4 watt. Let me check the answer. 50.4 watt. Then they say calculate the energy input to the heater in 8 minutes. Give your answer in kilowatt hour. So if you want to calculate the energy, the formula for the energy is power multiplied time, and the power should be in the kilowatts and the time must be in hours. So 50.4 watt, and you do want to, if you want to convert it into kilowatts, you divide it with 1000. And time is in 8 minutes. So if you want to convert it into hours, you divide it with the 60. So 50.4 divided 1000 multiply 8 divided 60, and you will get the answer 6.72 expo minus 3 kilowatt hour. Okay, so let's have a look at the marking. Yes, our answer is right. Okay, so let's move to the next part. During heating, the student notices about molecules of water. What happens during evaporation? You see, during the evaporation, the molecules of the water which have higher kinetic energy, they come to the surface of the liquid of the water, and they break the intermolecular bonds and they escape from the surface into the air. So let me show you my written answer. Water molecules with higher kinetic energy come to the surface of liquid and escape into the air. So let's have a look at the marking scheme. Molecules escape from the surface, leave water, become gas or vapor, break bonds. Faster moving, high energy, energetic molecules escape. Yeah, our answer is right. The next question is C, second part. He says, the student finds that the amount of evaporation increases when the temperature of the water increases, is higher. State and explain one other change that increases the amount of evaporation. You see, there can be different changes. For example, if you start blowing the wind with the help of some fan, because then the rate of evaporation will increase, because that wind will take away the vapors which have came out. So the air around the surface of the water will not be able to be saturated. So it will help to increase the. Another way can be that you increase the surface area of the liquid. When the surface area of the liquid is larger, more and more molecules will be able to escape from the surface into the air. Okay, so let me show you my answer. Okay. If the surface area of the liquid is larger, more molecules will be able to escape from the surface. That's our answer. So let's have a look at the marking scheme. So in the marking scheme, he has given different answers: wind, draft, breeze. Wind knocks molecules away. Larger surfaces, this is the answer which we have given. More chance possibility of escape, more space to escape, or more molecules come to near at surface, or decrease the humidity or drier air, fewer molecules return from air, and decrease the atmospheric pressure, fewer air molecules to hit during escape. Okay, so our answer is right. It says state two differences between evaporation and the boiling. You see, the boiling happens on a specific temperature, and the evaporation can happen on any temperature. It happens on almost all the temperatures. And the evaporation, the boiling happens throughout the body of the liquid. Evaporation only happens at the surface of the liquid. And during the boiling, the temperature changes. During the boiling, the temperature do not change. During evaporation, the temperature can change. And another very important thing is that the bubbles are formed in the boiling. During the boiling, the bubbles are formed in the liquid, but by the evaporation, no bubbles are formed in the liquid. So these are some differences you only have to write to. Boiling takes place at a specific temperature, while evaporation occurs on different temperatures. Boiling happens inside the liquid body. Evaporation takes place only at the surface of the liquid. So that's our answer. So let's have a look at the marking scheme. He says evaporation occurs at the surface and boiling inside the liquid and bubbles. Evaporation occurs at any temperature except room temperature. And boiling occurs at the boiling point, 100 degrees centigrade fixed specific temperature. Evaporation increased by draft, higher temperature, more area, and boiling is not, or increase in the pressure stops the boiling, but only reduces evaporation. So you have to write any two. Okay, then the D part is the student turns off the power supply and the water cools. Describe and explain how the convection in the air causes the water to cool. You see, basic question is that how the convection happens. The air which will come in contact with the water, that will become hot, and that its molecules will move away from each other. And what will happen? The air will become less dense. It will rise upward. The cold air will sink downward. This will set in the convection currents, and by them, the heat will be taken away from the water by the convection currents. Heat is also taken away by the conduction of the through the cup and then into the air. Hot water loses heat by conduction from cup to air. Air in contact with cup or hot water surface becomes less dense, rises upward, cold air sinks, and which is more dense, obviously. Convection currents are set in. So that was the last question. Let's check from the question paper. Okay, so this is the last part. Water heats air by conduction, or water loses heat energy to cup or air, or water gains heat energy from water. So air gains heat energy from water. Hot heated air particles rise, or cold air particles sink. Hot air is less dense, cold air is more dense. So you have to again 2 marks out of it. I think our answer is right. So, my dear students, we are done with this paper. So this paper is over. So My dear students, we have completed the section B of May-June 2013 Physics 505422 paper. This paper was from the zone 2 or variant 2. The section A of this paper we have already solved, and that has been uploaded in the YouTube. If you are watching this video first time, you should know that in the description of this video, you will find the playlists which are of the paper 1 from the zone 1, paper 1 from the zone 2, paper 2 section A zone 1, paper 2 section B zone 1, paper 2 section A and B zone 2. So, and I have also put there the playlist for the syllabus which we have studied in our 10 Cambridge and 11 Cambridge. So you can easily click just the link of those playlists and you will go to that playlist. If you find this video helpful, if you find this video interesting, if you think that this video has helped you to solve the past paper of the physics, please subscribe my channel. Also share the link of this video onto your Facebook, onto your Instagram, and onto your Twitter account. Also like this video. Share the link of this video with your friends. So thank you very much for watching my video. Have a good day. God bless you all.